Move the function selector to the ohm setting as shown by the Greek letter omega. This setting is also for selecting continuity buzzer and the diode test. Ohms are the default setting. The ohm meter reads in ohms, kiloohms, and megaohms units. The ohm meter is best used to measure the resistance of isolated components removed from the system.
My guess anyway, and I read, if I read anything, I read 25 ohms. So this is the coil. The only thing in the relay that has resistance or should have resistance is this coil, and the two smaller terminals mean that's the coil.
When the ohm meter is used, the external circuit must be isolated or disconnected for the reading to be useful. This process requires a great deal of time and is often difficult to do.
Ohm meter, okay? A couple of things about the ohm meter. The ohm meter is on the same setting as continuity and diode check, so you flip it over to ohms, okay? It's auto ranging now, and leave it there. Do not hit this range button unless you need to, and the only time you're going to need to, as far as I'm concerned, is testing rheostats and potentiometers, and that means throttle position sensors and things like that. Key things about the ohm meter. The circuit must be isolated. You have to isolate the circuit. If you don't isolate the circuit, the reading won't be right. And isolating the circuit can be either as simple as pulling a bulb or a relay or opening a switch, or it could be as complicated as having to pull every marker light on this truck. So isolating the circuit is the primary reason that the ohm meter is so difficult to use. It requires time to even get the system to a point where you can make the test in the first place. So any time in the past where you've measured ohms and you haven't been isolated, the reading was more than likely wrong. Now another thing about the ohm meter, it requires a prediction. Like I said on volts, it requires a prediction. Why are you at that wire? Why are you not at the other wire? Why did you test here? Why did you test there? Why are you pulling the dash out? Why are you doing these things? Well, it's because you're trying to find the problem. And you're hoping that what you think is the problem, and we know that most of the time it's not. So the ohm meter requires a prediction. The voltmeter does not. So if you're going to use the ohm meter, the circuit has to be isolated, and ask yourself, why am I here? Why am I doing what I'm doing? Why am I measuring what I'm measuring? If you can answer that question with absolute certainty, then go for it. No problem at all. But the majority of the time, the ohm meter is a harder meter to use. It works really well if you have the component removed and in your hand. Okay? But whatever you do, don't get your fingers in here. If you get your fingers in this reading, you screw it up. Okay? So keep your fingers out of here. Don't let your fingers touch the probes. Got 4 terminals, 5 on here. We're only using 4. These are the coil terminals. Those are the big contact terminals. This is the starter relay. Okay. So I'm going to go to ground, and I'm going to read voltage here, and nope, no voltage there. But yep, I got voltage there. Now I'm going to load it, and it loads good. So everything from this terminal back to the battery is fine. Now what I'm going to do is flip it to ohms, because I'm going to assume that this terminal right here is going to go to the starter solenoid, which I'm going to assume is going to be about 5 to 10 ohms or less. It's even less. It's 0.5 ohms, which is really low, but it's not 0, okay? 0.5 ohms is not 0.